Next time we'll tape you.
Okay.
Well, you will realize that most of the materials have a secondary purpose. They have a main purpose, and then there's also something ingrained in the material that leads the children on to the next step. And in the very early years, the child has the type of mind that takes anything that is in the environment. Dr. Montessori calls it the absorbent mind. And if you give the children music at that time, or sensorial materials, or mathematical materials, then they get a predisposition to enjoy and understand good music, or good art, or mathematics, or whatever. And this is why so often children seem to inherit a faculty from their parents, when we know there isn't a gene. But the parents enjoy something in the home, and the very young child absorbs what the parents are interested in. You see, after all, they're trying to imitate the parents very closely. It's the only way in which they can develop and mature and become adults themselves. But before the stage of sort of conscious reasoning, before they have enough knowledge with which to reason, there is this very early period of absorption. She calls one of her books, the book on the first year's the absorbent mind. So you will have noticed that in giving some of the materials to the children, we have already given mathematical concepts, with the cylinders, concepts of size. And also there are 10 cylinders in the block as a preparation for the decimal system. You see the pink tower, the broad set, the long rods. Again, conceptions of size, but 10 of each group. The geometry cabinet, which we had last week, gave a full classification of shape. And in fiddling about with those shapes, I gave you some idea of how the children discovered geometrical concepts. They found the circle will spin. They can turn it round and round in the wooden frame. They find that the rectangle has to be turned through an angle of 190 degrees in order to fit it another way. Some shapes won't fit in any one way, and so on. And so when the child seems to be just idlingly playing with that, you must always watch, because he may be gaining important knowledge. Well, now, we do have certain things for them to use, which will later, which will help to build up this mathematical mind. And when they come to the subject later, like the geometry, they will already know so much that they will be predisposed to enjoy the geometry. But when it's the cube of the binomial I'm going to show you today, and when a 3.5 or 4-year-old, 4.5-year-old uses this, nobody says that they are consciously understanding cube root. But by using it, taking it apart and putting it together, and when we show the child to take it apart, we do show him to set it out in the formula, you see, so that not in a haphazard way. So that when he does it in this exact way, you see, later he will be developing these mathematical concepts. Now I'm going to work it with you mathematically on the board first, you see, but of course you wouldn't do it that way with the child. You being an adult, so I want to refresh your memory of what you did at school. First of all, take the cube out of the box. Okay, hold it up on the lid. You wouldn't do it for that for the child. And you see each face of the cube, each edge is so many tens, so many units. so many tens, so many units. So that each face shows the square of the binomial. 10 squared plus 2 rectangles of tens times units plus units squared. You see that? That measurement is so many tens, so many units, so many tens, so many units. Then this, which is a square, is the square of 10, isn't it? This, with its units, is the square of units. And this, which is 10 tens by units, would be a rectangle of tens times units. And here's a rectangle of tens times units. You all see that? Tens times units, tens times units. So this is the square of 10, square of units, and this is a rectangle 10 times units, tens times units. So that's a square tens times units, a rectangle tens times units, and a rectangle of tens times units. Now, each face, you see what I have to say on that. I'm going to take it off the lid. And the color helps to show that. Going to have the cube of the trinomial. Binomial is a number composed of tens and units. Now, we could say tens times units or cube, or when we do it algebraically, we say A plus B or cube, don't we? Now we'll do that. We take A plus B, and we have to square it first, so we multiply by A plus B. And A times A gives us A squared, and A times B gives us the rectangle A. Now B times A gives us AB. Just, we can say 3 2s are 6 or 2 3s are 6. And in algebra we put the A for B. And B times B is B squared. So we get A squared plus 2AB plus, and that is the pattern we have on the face, each of the faces of the cube. But we have to cube it, so we must multiply this by A plus B. So we get A cubed plus 2A squared B plus AB squared. Now we multiply by A, we must multiply by B, and we get A squared B. We get 2AB squared. And we get B cubed. Now that's your formula for finding the square root of a number. And this is your formula for finding the cube root of a number. And it's this that we're going to demonstrate. Now, this is the line where we multiplied by A, and this is the line where we multiplied by B. So when we take the cube apart, we're going to be very careful to set it out. The one layer will give us this, and the next layer will give us this. I'll lay it out as though you were the children, you see. Here, I take this piece, and you will find wherever we have the square of A, the face is colored red. The colors have no significance in themselves. At different times, different colors are being used. But in this particular one, it's red. Now, each face is red, so that is a cube. So that's A cubed. Now, the next two pieces, so you have the square of A, but the side pieces are rectangles, A times B. So here we have A squared B. You see, A times B gives you A squared B. There are two of them, A times B. So we have our 2A squared B. And now we take this piece. This measurement is A. That measurement is B. That is B. So we have A, B squared. And all faces which are B squared are blue, and all the rectangles which are A times B are black. So there we have this layer, so this line, which is A cubed plus 2A squared B plus A B squared. Now we have to get this. So we start with A squared B. A squared B. Now we have 2A squared B's here, so this one has to go underneath those, but we place it so that it is height B, because this is where we're multiplying by B. Everything here is height A, this line is going to be height B. Now we take the next two pieces, which are the same, and their measurements are A, B squared. All right? The measurement is A times B, so it's AB squared. Now we have one AB squared here, so we must put these underneath that one, but we put them at height B. And then our last piece is B cubed. So A cubed, 2A squared B, AB squared, A squared B, 2AB squared, B cubed. And if we add those, we get the last line. We get A cubed, 1, 2, 3, A squared B, 1, 2, 3, A B squared, B cubed. So we set it out like the formula. Now, of course, we're not saying anything to the child. They wouldn't understand, given you the arithmetical or the algebraic reason for what we do. With the child, you just take it to pieces fairly slowly, letting them see what you do, and set it out on the table like that. And then you show him how to rebuild the cube. And you're just going to take each piece in order. A cubed. And you let him see that you are matching a red face to a red face. So at first he does match by color. Now the faces here are black. So this third piece we match the black faces to the black faces. And we have built the first layer of the cube. And if we look at it, you see there we have the a plus b all squared. There we have the a plus b all squared. We don't show the chart there, I'm just showing you. We only built it for the chart. Let him look at it, and then we take a squared b, and we let him see that we're matching those two red faces. Now here we have black faces, so we take a b squared and match those black faces to the black faces. A, b squared, and do the same, matching those black faces. Now we have three blue faces here. So we match b cubed. So. Well, I've given you the explanation. Now if I was doing it with a child, further start the cube. I would be sitting there with the child. And I wouldn't need to say anything. I'd let him look at the cube, get him to look all around and on the top, so that he saw the repetition of a plus b squared. Look at that for a minute, and I would show him how to put it together. I could say to him, we're putting the red faces together, if I felt that would help him to understand. Matching black faces. But usually he doesn't need that explanation. A times B is a rectangle, and this measurement is A and that measurement is B. It's a rectangle of size AB. A times B, AB. That's all right now.
Before you, if you're not explaining to the child what's going on, what is the purpose of doing this per se?
Because at this age he has an absorbent type of mind, and whatever is in the environment he absorbs. And if there are mathematical things in the environment, he does seem to become interested, he gets this predisposition to understand and enjoy math. And we've had the overwhelming proof time and time again that children who are exposed to math, but not made to do it, not made to understand it before they're able to. See, perhaps the father does mathematical things around the children. I think I told you about the children on the hill. The father was doing a very poor laboring family. The father was doing a correspondence course in mathematics, and they only had the kitchen table to work at. A very poor family. And the little boy, who related very strongly to his father, used to like to sit on his knee in the evening. And the father, who had this work to do, used to have the little boy from the age of about 2.5 on his knee, and in order to keep him happy and quiet, just did everything out loud. And this child became a mathematical genius. It's not through inherited genes, it is that you do absorb in these early years whatever is in the environment. One of the reasons why we have to be so very careful of our behavior in front of a small baby who's lying in the cot. It does absorb the treatment it receives, and that is what it gives back again as an adult parent. So it's not an inherited instinct, it's the instinct you acquire during your first year of life and the way your parents handle you, particularly your mother. So, in giving them these things, they are becoming interested in mathematical concepts. They're getting this predisposition to understand math later. And you'll find them when they do these later, the whole thing lights up because there's this sort of previous interest.
Building the cube is easier than laying out the cube.
I wouldn't have thought so. I think you take it piece by piece, as I did, slowly I don't think it's effective.
So then you would continue to correct the layout, even with a child?
I don't, always we don't correct a child when he's actually working. We give a new lesson, the next day, 8 in the morning, showing again very carefully the layout. And for most things, the child does need more than one lesson. He takes in so much, he does it, and then he probably needs a second lesson in the handling or the layout or the using it quietly.
In order to begin again, if you were going to repeat showing the child how to use that material, the first one you laid out was the total breadth of A cubed. Right?
Yes, so this is A plus B or cubed. And the first one I take is A cubed.
And isn't that on the bottom when you first, after you've built it, it's on the bottom?
Let's do that. That is A, that's B. Now, I could take this build from here, in case I'm building the second row first. Or I could take it's very easy. Do that instead. Try. Now you can see that with this one, the child is matching color to color. And he will be very much more aware of color than of size. But we really want him to draw his attention to size, the fact that this is a square, you see, this is a rectangle. So when he's had this to work with for some time, I like to give a second cue. The second cube is the same as the first, except that there's no color. It's just plain, lightly varnished wood. I think it's much more beautiful in just plain wood. But you use it in exactly the same way. Start with A cubed. And you have to recognize that this face is the same size as that face. It's A squared. This one you have to recognize the faces by size. I think that the child gets a deeper understanding when he can do this well through using this one.
That after they master the first one, or do you just let them do the first one and then do the second one by themselves?
Or they would have this one for quite a little while. They would be setting it out and rebuilding very easily and with real competence. And then you could demonstrate this.
After they work with the color for a while, they learn to put it together without really worrying.
Both to put it together and to set it out.
Do you really stress the way that they set it out?
Well, I do from the beginning. It is important to set it out, yes. So say you don't correct them if they're using it, but you would give a new lesson the other day, the next day, again showing them how to set it out. I think you do need, for the sake of mathematical understanding, to set it out according to the formula.
Can I understand you refer to it as the cube or the
Cube.
binomial?
The cube of binomial, or the binomial cube. The children all call it that. They have no difficulty in learning words.
It's binomial.
Binomial cube, yes, or the cube of the binomial. Children learn language very easily. They can learn a great number of words in one day. We don't feed them words nearly fast enough, and knowing these terms again will help them in their later mathematics because they will know the words which they need to know in the special subjects and which they find difficult to learn later on. The more words they learn at this age, the more easily they will add words later. So we don't have to be afraid of any word. It's no harder to say binomial than it is to say automobile. Is it?
Television.
Television, up the staircase. No. All the words we expect them to know. There's a barrier in our minds because we didn't know what we were doing when we started algebra. You want to say something? All right then. So, news there is this afternoon.